यहाँ से पॉज कर देती हूँ और ये हो गया प्ले।
ये है ना चालू करिए आप।
अब एडमिट भी करने की जरूरत नहीं पड़ेगी, हो जाएगा। नहीं।
Hello students. Hello. Hello students. Stop sharing करो।
नहीं सर वो नहीं, उसको स्टॉप नहीं करना। ये यहाँ से म्यूट करना होता है क्या म्यूट करना होता है? एक बार और देखिए बच्चों को, तो बच्चे की आवाज नहीं आ रही है ना, म्यूट ही तो हो रखा है वो।
आवाज जा रही नहीं जा रही है किस?
ये जैसे इनके आ रहे हैं ना ये सब,
ये वो लोग अभी नोट कर रहा है। सही लोग हमने किसी को अनम्यूट नहीं किया। खुद ये पूछो, ये म्यूट करो। एक बार पूछ लो सर उनको, बोल दो आवाज नहीं आ रहा तो आप चैट बॉक्स में कमेंट कर दीजिए।
उनसे पूछो।
नहीं ऐसे इसमें बोल दो ना आवाज जा रहा है, ऐसा नहीं कि आवाज नहीं जा रहा है।
Hello students. Hello students.
Yes sir.
Hello students.
Yes sir.
Okay. We discuss about the sulfonation of aromatic compounds. Okay. First of all, we discuss about the reagents which are used for the different reactions, and these reagents are classified into two classes. Number one is electrophiles. Electro means electron, file means loving. Electrophile means electron loving reagents. Reagent which can accept an electrons pairs in a reaction is called electrophile. That is electron loving agents. They are electron loving reagents that attack on highly electrons density region, that is ortho meta para positions, at which density of electron is higher in the molecule. They are electron deficient. These agents, electrophiles, are electron deficient. They may be positive ion or neutral molecules with the electron deficient centers. And nucleophiles, a reagent which can be nucleophiles, a reagent which can be having the electron pairs in a reaction is called nucleophile. Nucleophiles means nucleus loving reagents. They attack on region of low electron density, that is a positive centers in the molecules. Nucleophiles are electron rich. They may be negative ions or neutral molecules with free electrons. Examples: Cl minus, Br minus, I minus, means this is the anionic. And now we discuss about the sulfonations. Sulfonations means introduction of sulfonic group in the aromatic compounds or aromatic rings. And general methods of sulfonations are when an aromatic compounds react with the fuming H2SO4 or concentrated H2SO4 forms respective sulfonic acid. For example, benzene. When benzene reacts with the fuming H2SO4 means having the sulfur trioxides, and this fuming H2SO4 reacts at room temperature and we get the benzene sulfonic acids. And you can see the second one is benzene in presence of concentrated H2SO4. This is the simple concentrated H2SO4, and so that we heat it at higher temperature more than 100, that is 120 degrees centigrade, and then we can also get the benzene sulfonic acids. Hence we get the sulfonated benzene. This is the sulfonation of benzenes. Okay. Next is toluene. This toluene goes under the sulfonation reaction with concentrated H2SO4 at 120 degrees temperature, and we get the para-toluene sulfonic acids, and along with we get the also orthotoluene sulfonic acids. These are the two products, but this the para product is more stable. Mechanism of sulfonations. Sulfonation is carried out in the following steps. Number one step is, in this step, electrophile is formed. And here the electrophile is sulfur trioxides. You can see in the reactions, H2SO4 goes under the reversible reactions and it forms the sulfur trioxides, hydronium ions, and HSO4s. And this sulfur trioxide is electrophiles. Step 2, these electrophiles, that is sulfur trioxides, attack on the benzene ring to produce the carbonium ion or carbon cations. You can see in the structures. This is the benzene ring and this is the SO3. This is the electrophile which attack on the benzene rings, and you can see this is the pi electrons. This is the pi electrons, and these pi electrons goes to the sulfur trioxides, and here the positive charge is formed due to donation of electrons. And you can this is the intermediate product, that is carbonium ion, because this is the carbonium ion plus charge on the carbon atoms or carbon cations. And we can write it also like this. This is the H and SO3 minus. And this intermediate carbonium ion is resonance stabilized. It is a hybrid of the following resonating structures. You can see, and this is the positions in the previous figures, and you see this the pi electrons go to this here, transfer to this carbon atoms, and we get this type of structures. And the position of sulfonic groups SO3, sulfur trioxides, and hydrogen, which is part of benzenes, are there. And next, these pi electrons moves to this here, and we get the structure of this. These are the three resonating structures. And step third is proton is removed. Here's the hydrogens replaced. So these hydrogen goes to these positions, and it again it forms the pi bonds, and there is an alternate bond is formed here, and HSO4s reacts with the sulfonic groups, and it forms the SO3 minus in the benzene ring and S2SO4 here. It is clear from the first stage. HSO4 is formed in the, you can see in the reactions here HSO4 is formed. And next step is proton is removed, and this the HSO3 minus and HSO4 is formed, and SO3 minus is formed, S2SO4 is formed. In the step 4, proton is added, and it is from the also first stage is the hydronium ions react with the sulfonic minus ions, and this the benzene sulfonic acid is formed. One hydrogen is removed, and from the benzene rings, and this is the substitution reaction, and sulfonic group is added to the benzene ring, and water is formed. So we can get the benzene sulfonic acids by the process of sulfonations. And this is the mechanism of the sulfonation process. And we can also get the benzene sulfonic acids by oleum or fuming H2SO4s. When benzene is treated with the fuming H2SO4, fuming H2SO4 means we have the sulfur trioxides in the sulfuric acids, so that we can get the H2SO7s. And this is the fuming H2SO4s. When treated with the benzenes at room temperature, we get the benzene sulfonic acids, and we get the sulfonated benzenes. Number 2, by the use of sulfur trioxides in carbon tetrachlorides as a solvents. You can see benzene when treated with the sulfur trioxides in presence of carbon tetrachlorides, and we get the benzene sulfonic acids. By the use of thionyl chlorides or sulfonyl chlorides. Here you can see this is the benzene ring, and SOCl2 is treated in presence of H+, that is undergoes the reduction process, and we get the benzene sulfonic acids. And you can also see this is the chlorosulfonic acids treated with the benzene, and we get the SO2Cl sulfonyl chlorides, and in presence of reducing agent we get the benzene sulfonic acids. Number 5, by the use of thiophenol in presence of alkaline KMnO4, here get the oxidation process, and is thiophenols goes under the oxidation. This is the KMnO4, and this is the alkaline KMnO4. In presence of alkali, it acts as a oxidizing agent, and it forms the benzene sulfonic acids. Hence, we get the benzene sulfonic acids or introduction of sulfonic groups in the benzene by the different process. Now we discuss about the sulfonation of aniline. Here you can see NS2 in the benzene ring when introduced. This becomes aniline. Aniline have these nitrogen atoms have the lone pair of electrons, and this lone pair of electrons goes towards the benzene rings. Means this group is electron donating groups, so that we can get the ortho and para products, as we discussed in the previous classes. Ortho and para products is formed due to electron donating groups. When electron goes from the groups to the system, this is the system, alternate bond, that is benzene ring system, double bond, single bond. This is the alternate bond systems, and this is the benzene, and this is the group. From the group to electron goes towards the system, that is the alternate bond, single bond, double bond systems, so that we get the ortho and para products because of a higher density of the electrons at the ortho positions and at the para positions. We can discuss it, this mechanism we discussed in the previous classes. Sulfonation of naphthalene. When naphthalene reacts with the concentrated H2SO4, it forms the following product. There is two types of products, alpha product and beta products, as we discussed in case of naphthalenes. Naphthalene produce the alpha and beta products. Naphthalene alpha sulfonic acids or one sulfonic or monosulfonic naphthalenes and two sulfonic naphthalene acids. And you can see here the naphthalenes, and this is the number one carbon atom 1, 2, 3, 4, then 5, 6, 7, 8, and here 9, and just below 9 this is the 10. This is the numbering system of naphthalenes. So when this naphthalenes goes under the sulfonation at 80 degrees centigrade for 8 hours, we can get the alpha product of sulfonic acids, that is a one sulfonic acid naphthalenes or alpha sulfonic acid naphthalenes, and this is the beta sulfonic acids, and 96% alpha product is formed, so that beta products can be separated. Naphthalene disulfonic acids. These are the monosulfonic acids, and now we discuss about the naphthalene disulfonic acids. This can be prepared by direct action of oleum on naphthalene or sulfonation of naphthalene monosulfonic acids. Means we can get the disulfonic products from the naphthalene, as well as we can get the disulfonic products from the monosulfonic naphthalenes derivatives. You can see in the first reactions, naphthalene when treated with the oleum, this is the 64% sulfur trioxides. Oleum having the 64% sulfur trioxides, and in presence of 100% sulfuric acids, and temperature we maintain 40 degrees centigrade, and time is 8 hours, then we get the 1,5-disulfonic naphthalene or 1,5-disulfonic acids. Naphthalene 1,5-disulfonic acids is obtained, and these are separated by diluting with the 4 parts of water, and there is no need of further purification, and it is used in the manufacturing of azo dyes. And second, our second product is naphthalene 1,6-disulfonic acids. When naphthalene is treated with the 100% H2SO4 at 165 degrees centigrade for half an hour, then we get the naphthalene sulfonic acid, alpha naphthalene sulfonic acids, and further it is treated with the oleum at 40 degrees centigrade for 9 hours, then we get the 1,6-disulfonic acids. naphthalene 2,6 and 2,7 disulfonic acids products can be also manufactured, and these are obtained by sulfonating of naphthalene with concentrated 100% sulfuric acid at 160 degrees centigrade for 8 hours, and 2,6 disulfonic acid is separated from 2,7 disulfonic uh, as insoluble barium salts. You can see in the reactions, naphthalene is treated with the 100% concentrated H2SO4 and it forms the both products, 2,6 disulfonic acids product and 2,7 disulfonic acids product. Now, naphthalene trisulfonic acids, and here 1,3,6 trisulfonic acid is obtained by sulfonation of naphthalene with stronger oleum at 170 degrees centigrade. When naphthalene, you see in the reactions, naphthalene is treated with the stronger oleum at 170 degrees centigrade, and we can get the naphthalene 1,3,6 trisulfonic acids. And it may also be prepared by these reactions. You can see in the naphthalene, naphthalene 1 to 3 trisulfonic products can be also manufactured from disulfonic products, and disulfonic products are, this is the 1,6 disulfonic products, and this is the this is the 2,7 disulfonic products, and by the treatment with 40% oleum at 160 degrees centigrade, we can get the 1,3,6 trisulfonic acids. And tetrasulfonic acids, and when the 1,5 and 1,6 products of naphthalene is treated, then we get the with the H2SO4s, and we get this one trisulfonic products, and when trisulfonic products goes under the sulfonation, we get the 1,3,5,7, that is the tetrasulfonic acids of naphthalenes. So this is the all about the sulfonation of benzene and naphthalenes. Thank you, friends. अटेंडेंस भेज देना आप लोग.